So here, where are we now? Are we here? No, we did that. Here we are. Here we are. All right. So usually what I did was went into the games, but instead we're going to go into our woman, right? We're going to try to understand what this means because, I'm going to give you this question, and I bet you right now half of you won't know what this means, right? How many of you feel you know what this means? How many feel you have no idea what this means? How many people would never put up your hand, no matter what? He put up his hand. All right, so let's build it backwards. What does the subsequence say about its free variables without emphasizing the bounded variables? All right, that's what we're going to try to do, right? So we're going to start on the inner core. Now we have two free variables, right? What does it say? It says they add up to 0. Right? What does that mean? They're kind of, in my world, it means they're additive inverses of each other, right? Here, they're additive inverses, right? If one is 2, the other one's -2, right? So we have a relationship here. They're additive inverses. All right, so now let's build it out further. Right? Now our free variable is x. What is it saying about x? X has the property that it has an additive inverse, right? X has an additive inverse. Right? People see that we're talking about x, and that's its property. Then we come out here. Now we don't have any free variables, so sort of we're still talking about x. What are we saying about x? Every real has an additive inverse. See how we translated that into a sentence? Is that what everybody was more or less saying? Right? Every x has an additive inverse. All right, so what about this? What does this say? Again, we have additive inverse, right? And here we say, what are we saying here? Every real is an additive inverse of y prime. We're talking about y prime. What do we want to say? We want to say every real is an additive inverse of y prime. Right? Is that, we're going toward no, right? We're going towards a no. Yeah?
So you are meaning there exists a specific y?
No. Y is our free variable, so y is our input to our question. No, we're talking about y. Is this true? It depends on who y is, right? Now, for our given y, what does this say? What does this say about y? It says every real is an additive inverse of y, right? Which, of course, is not true, right? So now what does this say? Well, which y? You were asking before, which y are we talking about? So now we're saying there is a y that has this property. Right? There is some y which is such that every real is the additive inverse of y. Is that making sense? You have a question? People good here? And is this true? Clearly not true. Right? It's clearly not true. All right, so here's another sentence, right? Here I changed it from x plus y equals 0 to x plus y equals x, right? And now we can ask, what does this mean, right? And I can say, well, I have a number x and I have a number y, and what's true about them? Well, adding y to x doesn't change x, right? That's kind of what it's saying, right? And then I bring it out. What does this say? Well, I need to say something about y. What am I saying about y? I'm saying no matter what you add to it, it makes no changing, right? Here I didn't talk about x. You note, I didn't talk about x at all. I just said, what's true about y? You add anything, you add to it, and it doesn't change, right? So now we're saying there exists a y that has this property, right? There is some y that if you add to it, it doesn't change. Sorry, not that it doesn't change. It makes no changes. Sorry, I was starting to think, this sounds wrong to me. Let's back up because I was saying wrong things. Right here, adding y doesn't change x. Here we're saying adding y doesn't change things. If you add y, it doesn't change the x. Right? That's what I meant to say. Right? If I say things that aren't on the slides, then say, Jeff, you're saying it wrong. Right here we're saying what's true about y is if you add y, it doesn't change what you're adding it to. And is there a y for which that's true? Yeah. 0 has the property that if you add it, it doesn't make a change. Yeah?
So basically, when we're making these statements into words, we're just mentioning the free variable.
That's my intuition. I'm just making this up, right, to figure out how we can do it. And my intuition, I'm trying to think, what am I doing? I'm getting it right. You're getting it wrong. What am I doing differently? And I try to think about that. And I'm trying to think, well, I'm building it up like this, right? If I see this, what do I want to say about this? Somehow it's telling me a property of y. And so I'm hoping you're the first trial to actually do this. All right? So let's see if you guys can build up sentences and know what they mean. Yeah?
So what's the difference between this one and saying like for every x there exists at least a y and doesn't change it?
So which x plus y is?
Yeah, what's the difference between this one and that one?
What do I got here? X?
Yeah.
Yeah. And this one?
Yeah, what's the difference between that one and the last one?
It's the order here, right? This is saying every x there exists a y. Each y can be different for every x, right? Here, for every x, there's a different y, right? Here we need one y. The y comes first. This is the key to knowing the difference between there. Here, for every x, you give me 2, I can give you negative 2. You give me 7, I give you negative 7. But can you give me one y that's the inverse of every x? No, right? But here, I can give you one y, namely 0, that no matter what x is, if I add 0 into it, it doesn't change. Right? The point is that there's one y that works for all of them. Right? 0 works for them all. That is the crux that I'm trying to drive in, is the difference between these two statements. Everybody good? Okay, what are we? Oh, yeah. So, okay, reals. So let's do it again. No, now we're doing it the proof. We're doing the same examples, but we're going to prove them. All right? So here, if we're trying to prove this, then who goes first? The adversary comes up with an arbitrary real, right? And then the prover gets to come up with a y. And what is his y? As we've been saying, it's the additive inverse, right? And then we see whether it's true, and it's true. So this is a proof, right? I don't know how this I'd be curious to know how you prove this in 1090, right? Certainly those first set of axioms, 8 to 6, just scared me, right? I didn't know how to prove anything with those. Right? Everybody good here? Maybe somebody can help me understand 1090, because I really don't have it yet. So, everybody good with this proof? Here, note the subtlety. Here we're saying, let x be an arbitrary real. Now, we're playing the game, right? So I come up with the y, knowing x. What is my y? My y is negative x. So yeah, it's a function, right? It's a function of the x. And then it's true, so I win. All right? So now, and it says every real number has an additive inverse, right? It's true, right? And now what about this? The order really matters, right? What's the difference between them? Now, oops, that went fast. Where do we go here? Oh, that was the one we did. Now we're doing this one, right? Now I have to come up with a y, right? I have to come up with one y, and I'm panicking. Why? Because I actually already know it's not even true, right? What y can I come up with? And what now? This guy, the adversary, knows my y and comes up with an x, right? And what's his x going to be? It can be negative y plus 1, right? So then, now you add them together and you don't get 0, right? Y plus negative y plus 1 equals 1. It's not 0, right? People see that? In fact, what we did, if you note the nuance of what we did, if I said let y be arbitrary, right, what we did is we just proved that the negation of this was true, right? The negation is for all y, there exists an x, that x plus y is not 0. That's what we're doing here. Let y be arbitrary, let x be negative y plus 1. Look at it doesn't equal 0. Here we more or less just prove the negation. Right? So this is false. Right? So now we've come to the third again, right? Who wins, who goes first? Right? Right? We need a single y that works for them all. But we don't have it. So now we come up with the third example. Now we're going to, you'll note the pattern here. That's what we're going to do in all of our examples. We'll get a for all exists that's true. We'll get an exists for all that's false. We'll get an exists for all that's true. That's what we're going to be doing in this game, right? So how is this true? Well, I want to prove it's true, so I get it to assign an x. Let x be 0, right? Because I think it's true for 0. Now, so then can I go on my proof like this? I can say, well, look at x plus y equals x. It's true for all y. Is that a proof?
No. False. For example, if 1 instead of y,
oh, no, but I'm just saying there exists a y.
That might be a typo. It should be for all x.
Where are we?
At the bottom line.
Bottom line. Oh, for all y. All right, good. Okay, in fact, I have to remember where my typos are. If anybody ever wants, people can mail me my typos. There's a typo. Okay, this is what I meant. Let's go back. Right? Is this a good, right now, right? Right, so people write this is what I meant. Is this a good proof? Right? It feels like a good proof. And for something this simple, it's a good proof. Right? And I'm going to give you a 0 if I ask you to prove it. All right? And the reason I find often when I'm trying to teach someone is to follow a bunch of steps, a bunch of rules. And so I give them an example. And if the example is so easy, they can do the example without following my rules. And so they don't follow my rules and they haven't learned it. But if the example is too hard, then the example is too hard and so they fail. So what we're going to do here is I'm going to give you an easy example and you're going to follow my rules. Right? So here, what are the rules? This is not the game, right? So let's do what's the game, right? The game is, I want my proofs to look like this. The proofs are going to be, just like in 1090, you had to make the proofs in their proof system. Now you got to do the proofs in my proof system because I'm now the boss, right? All right, so here, what's my proof system? We're going to play the game. There exists the y, let y equal 0. Right? Now, we let x be an arbitrary real number. Right? Now we have an x and a y. And then we see if it's true. Is it true? Yes, it's true. So we win. Right? Everybody good with that? It's not a big difference. But, when we get to really complicated games, we want to know the rules. Right? All right. Oops. What are we doing? Oh, here we're doing another one. All right? You can think about what this means. In fact, it's very similar to our last one. Right? So again, we build up our understanding. What does this mean? This means that they're multiplicative inverses. Right? We're doing the same thing except multiplying. Right? This says x prime has a multiplicative inverse. Right? Everybody got that? What does this mean? X prime has a multiplicative inverse. What does this mean? This says every real has a multiplicative inverse. Right? People can see how we're building this up? Is it true? Why is it not true? 0. All right? So what about 0? Good. So what about this? Right? This says there exists an x that for all y, x times y is not equal to 1. Is that true? Right? Yeah, exactly. Right, so we're saying, here, this one back here is saying they're not multiplicative inverses of each other. This one says x prime has the property that it doesn't have a multiplicative inverse, right? This says x prime doesn't have a multiplicative inverse. This one says there is a real that doesn't have a multiplicative inverse, right? And that's, in fact, these two are what? They're negations of each other, right? Everybody good? All right. So, except for 0. So now, I've had this on tests, and you know everybody, this was a long time ago, because everybody gets it wrong, so I don't put it on tests anymore. I mean, one thing I learned is just, what can I expect from people, right? And this is, now we want to write down a first-order logic statement that says, every real has a multiplicative inverse except for 0, right? And I have slides which we can work this up, but let's just bang and, right? So one way of doing it is to have this range thing that we were doing before, right? Here, I'm not doing except 0. We were ignoring negatives as well. But, you know, you can imagine this is good. For every x bigger than 0, there's a multiplicative inverse. So that's a good statement, right? But the problem is maybe we're not allowed to do these range things, right? So as soon as you do this, it acts a little bit more like second-order logic, and we're not doing second-order logic. But anyway, let's forget about that, right? What do we want to be able to say? We want to say every real has some property, right? So this except, what do we, you know, we don't, right? Every real has some property. And what's the property, right? Right? We want this property to be true for all reals, right? We're looking for a property that's true for all reals. So what are properties? Well, one property is that x has a multiplicative inverse. That's one property we can talk about. And another property we could talk about is that x is 0, right? Now, if I want something that's always true, do I put an and or an or between these? Or what? Or what? If I put an and, is it always true? Well, no, x is not always 0, right? But if I put an or between them, is it always true? Yeah. So let's stick an or there, right? We're saying there exists, this says that x has a multiplicative inverse, and this says that x is 0, and I put an or between them. And then this statement's always true, right? People buy that? Now, one might argue, what does it mean that there exists a y such that x is 0? Well, that's okay. There exists a y for which x is 0. It's a funny statement, but it's not a, it's not a dumb statement. I mean, it's not a, right? So here I can bring the point is I can bring the y out, right? Here I'm saying there exists a y such that either x is 0 or x times y is 1. Right? People good there? Am I going too fast? People good? All right, so here's, oops, that kind of overlapped. That's funny. Here's our sentence. I think that whole thing probably was a typo. Right? So, and here I'm not even going to say except for 0. I'm going to say every real has a multiplicative inverse with one exception. Right? And I'm claiming that this says it. Right? People kind of follow that? And so let's prove this. I'm going to prove it. Well, there are two things we can do. We can, one, convince ourselves that it says this. Right? It says there's one exception, A, and then every x has the property that either it has a multiplicative inverse or it's our one exception. Right? People can kind of see that? So how do we prove it now? Now we're going to proofs. That was our discussion. Now we're going to go to proofs. Well, if we were going to prove this, let x be an arbitrary, let y be the inverse. Do they multiply to 1? Yes, they multiply at 1. It looks great. Right? It looks like we're good. But wait a minute, it's false. So we take the negation. What's the negation? It's this. Right? Now how do we prove the negation? Now I say, let x be 0. Then y, let x be 0, let y be arbitrary. Are people following along? Right? Let be y arbitrary. Look at, you multiply them, you don't get 0, you don't get 1. So the statement's true. Right? And now we try to prove this guy. We have our statement up here. Let's try to prove it. Right? This says there exists an A. And what is the A? What's the property of A? Well, it's our exception. It's our only real that doesn't have a multiplicative inverse. So there exists an A that has that property. Oh, let A be 0. Right? We're trying to prove there exists an A, let A be 0. Right? And now it's a for all. So let x be an arbitrary real. Right? Now we have to prove, now it's the y term. We're continuing the game. Right? So now my job is to come up with a y. Right? Well, I have x, so I want my y to be 1 over x. Right? But what happens if x is 0? Then I can't come up with 1 over 0. But I still need, to play the game properly, I still need a y. So let's make y 5. And people are going to ask, why 5? And I say, well, because if I said 6, you would say y 6. Right? So let's keep playing the game. Let's see if I win or not. We have a value. What do we have? We have a value of a. We have an arbitrary x. We have a value of y. We're going to check to see if this is true. Well, is it true? Well, there are two cases. If x is 0, then y is 5, whatever that means. But if x is 0, then x equals a. Right? In which case, this statement is true, because it's an or. And x equals or is true, so we're good, right? The other case, x doesn't equal 0, in which case y is the inverse of x, and we're good to go too, right? There are two cases. In either case, we're good. Right? Everybody see how we're proving this? All right. Right? So I can always win, so it's true. Everybody good? Now how are we doing for time? 3 minutes. All right. Anybody want to talk about anything for 3 minutes, or should I do more material? Concerns? Thoughts? No thoughts? Yes. The last part. Good. Good question. That's the button that makes everything break. All right, so where are we? We are just about to classify functions, so we can go backwards. Where are we? We're going backwards? No, we're going forwards. Here? All right, so what I'm trying to do is set up a set of rules that you have to follow and insist that you follow the rules, right? And in this game, the rules are you have to play this game. So I'm trying to prove that the statement's true, right? So the rules are, if it's an exist, I have to come up with an A. So I made A 0, right? And then if it's a for all, we're going to say, let x be arbitrary. And if it's an exist, I have to come up with a y. And I have this weird way of doing it. I have two cases. If x is 0, then I'm going to make y be 5, right? And if x is not 0, then I can make y be the inverse, right? So now I want to see, do I win? Right? What I win is if this is true. Right? Is this true? Well, let's look. There are two cases. Right? Is this true? Well, if x is 0, well, x is 0, a is 0, so x equals a. And that means that this is true, which means the OR is true. Right? And in the other case, if x not 0, then y is 1 over x, so x times y is 1. In that case, this is true, and so the OR is true. I just said it again, but did that help? And I think we're out of time, so everybody have a fantastic... When do I see you next? Monday. No, guys, slow down for a minute. There's a tutorial on Monday, right? So let's talk about tutorials, all right? So a tutorial, I will come with nothing planned, all right? And your job is to come up with questions, things you don't understand, and we'll cover them, right? And, for example, what you could do, you could make sure you understand what we've covered and say, hey, I didn't understand that. Or you could read ahead and we could talk about it. Or you could do the practice assignments on the tests. On the web, there are a bunch of practice assignments. You could do them. Come with things to do, and we'll talk about them. All right? So I'll see, hopefully, all of you on Monday, and then all of you on Tuesday. Yes. Hey, come talk to me. Hey, I like how you nod at me. I watch people who nod at me, and so I don't know if you've noticed. I look at you sometimes, and I see, oh yeah, at least she's following it.
Oh, okay.
So do me a favor, though.
Sure.
If you're not understanding, do not nod.
Okay.
Right?
Yeah.
Some people just nod all the time. So I have to learn whether
No, I
you're
never do that.
whether you're an
Yeah.
honest nodder.
Yeah.
Right?
I
If
am
you're not
honest with
understanding, say, Jeff, no, we're not getting it.
Yeah.
Right?
Yeah.
Okay.
So what I understand that's not a good practice. We put a range or domain after this. This
It's
would be
sloppier.
better we do like that.
Yeah. Well, this is more formal, and this is people do it. We will do it.
Okay.
You need to be able to handle both.
Yeah. And for the negation.
Yeah.
So we cannot change anything. It's right after these two. Yeah. So when we want to do the negation, we cannot change this one. Yeah.
Yeah, because
We
this is
cannot
saying.
change the domain and range.
Yeah.
Yeah.
Yeah. I mean, I gave the example where we're going from there exists a boy to for all boys. That was obvious
Yeah.
that we keep boys,
Yeah.
right? And here it's not obvious,
Yeah.
right? So that's why I gave both examples,
Okay.
right? And so then you ask, well, which do you do? Do you do this domain or do you do, right? The domain has the problem that you have to know the rules of switching.
Yeah, so we
And
cannot change the domain and range.
yeah,
Okay.
you need to be able to handle both of these, right?
Okay, thank you very much. See you on Monday.
So for the picture,
Yes.
the class participation
Yes.
upload, can we not put our face on the forum or?
The forum's a separate thing. If you want me to recognize you, if you want to go to class participation, the more you do so I recognize you, the better. And if there are people who are asking great questions on the forum and are answering questions on the forum, and you have your little picture there, every time I go to the forum, I'll see your face, and then I'll remember you better, right? It's a separate thing after you post your picture so that I have it on my webpage. So then I'm like, I don't know your name, but if I see a name, I say, who is that? I go to the webpage, I do a search, and now I know who you are, right? It's just so that we can keep in dialogue.
Okay. Thank you, sir. Have a nice day.
So I have a question about this one. Why can't we say that y equals 1 over x, and we're saying y equals 5? Can't we say y equals 1 over x?
Well, what's 1 divided by 0?
Oh, yeah.
That's the problem, right? That's the problem. We can't. There's a reason. The whole thing that there's a counterexample is that 0 doesn't have a multiplicative inverse, right? We can't do 1 divided by 0, and that's why we're doing all this game.
Okay. Sounds good. See you on Monday.
All right, excellent.
Like y is equal to 5.
Mhm.
Like, can we say any number?
Yeah. The fact of what he was saying, we can't. No, not any number. We can't say that it's 1 divided by 0. right? We can't say that.
Anything other than.
Yeah. Yeah, I just needed to say something because the rules say I have to give you a value of y, and so I put in 5.
A couple of questions.
Yep.
Basically, so does this mean, I just wrote it inverse, but is it, there is a girl that exists that every boy loves, or is there a girl that that loves every boy? That's the thing, I'm kind of confused.
You mean is the girl loving the boy loving the girl?
Is there one girl that loves every boy, or is there, like, how do you say, like, is there a girl that every boy loves? Or is there one girl that's not?
Well, the first there's two. There's the correction of direction. We're assuming that this person loves this person, and so we're only talking about boys loving girls. We don't care what the girls want. Oh, we're out of here. Yeah, always kick us out. I'm gonna give you this. I'm gonna give you this.
I don't need that.
Not that one.
No,
This
Whoops.
one. This one. You need this one?
No,
Nope. All right. We'll turn it off. You want?
no, I'm using this.
All right. We can get out of here. Oh, the recording. Yes, good. Thank you. See, I'm still recording.